Hey guys, welcome to Coach Scott's Chemistry. All you Red Devil chemists, we're going to work on a couple of these 4S problems. Uh, we're going to work on problem 9, 10, 11 because they're all essentially the same ones. All right, these are percent composition. All right, and what we're trying to do here is find the total mass of these compounds and then find the percentage of the mass of each of these individual components. For here, this is dimethyl ether. We need to find the percentage of the carbons, the percentage of the hydrogens, and the percentage of the oxygen, right? So that means first I've got to get the total mass of carbon. So if I can do it like this, carbon has 2 in here, right? So that would be 2 times 12.011. Okay, hydrogen has 6 times 1.0079, and then oxygen has 1 times 16.00 grams. So if I do my multiplication, then I sum everything up. Okay, I'm on my calculator now. All right, so if I have 2 times 12.0111, and then I add that to 6 times 1.0079, and then I add that to, well, 16, I get a grand total of 46.069. 46.069 grams, and that's the total. All right, so I'm going to use that, and then I'm going to get my piece for the carbon. So 2 times 12.011 is 24.022. Use orange. 24.022. So if I take that mass of that, okay, and then I divide by the total, so let's find carbon. 24.022 divided by 46.069. Then if I multiply that by 100, that should give me my percentage. 24.022 divided by 46.069. I get 50 times 100. I get 52.1%. Alright, so that took care of my carbon. And you can see the mass is mostly coming from the carbon. Now let's work on hydrogen. So the mass of that is 6 times 1.0079, and I get 6.04. Do that's one in orders too. 6.0474 grams. So let's do hydrogen here. So if I've got 6.0474 and I divide by 46.069 grams, which again is the total, and I multiply by 100. So I got the part, I've got the total, and that'll give me my percent. So I've got that divided by 46.069 times 100. I've got 13.1%. 13.1%. So that's the amount of hydrogen that I have. Now if I look at oxygen, and there's only one, so that's 16 grams. 16 grams divided by 46, the total again, 0.069. I multiply by 100. That's going to give me 16 divided by 46.069 times 100. That's going to give me 34.7%. 34.7%, and that's going to be my answer right there. Again, not too hard. So what is the mass percent or percent by mass composition of aluminum silicate? All right, get another pen here. Oh, it didn't give me the formula. Gotta go back a little bit. So let's go ahead and write the formula. That's a +3. I know that SO4 is a -2 because I did my summer work and I memorized all those polyatomic ions. So if I do the crisscross method where I take the charge here, that means I've got to need two aluminums to balance out the charge there. And that means I need 3 sulfates. So now we're doing just what we did before. I'm going to go ahead and block those out. Okay, let's see. We got aluminum, and that's 2 of those. Then sulfur, I've got 3 of those. 3 times I got to cross the parentheses. And then oxygen, I've got 12 of those. Aluminum has an atomic mass of 26.98. Sulfur has an atomic mass of 32.06. Oxygen, we know, has an atomic mass of 16. So if I mass all that out and then I sum all that, okay, what am I going to get? So 2 times 26.98, I get a 53.96. So we got to see that. 53.96 grams. 3 times 32.06 is going to give me a 96.18 grams. Then 12 times 16, that's a lot of oxygens. That's going to give me 192.0. Okay, so I need to add all those up. 192 plus 96.18 plus 53.96. If I add all that up, I get a 342.14 grams, which is the sum of every one of those, right? So I've got the aluminum part, I've got the sulfur part, I've got the oxygen part. And if I add that up, that gives me my total. Now it asks for the percent mass, so let's work on that. So I've got aluminum. So how I work on that is I find out what the mass, which is 53.96 grams. And if I divide that by the total, 342.14, and multiply by 100, that's going to give me the percentage of aluminum, right? So 53.96 divided by 342.14 times 100 is going to give me 15.8%. 15.8% aluminum. Not bad. All right, now sulfur is 96.18. Excuse me. 342.14. That would be 28.1%. Write those down. 96.18. About 342.14 grams times 100. It's going to give me 28.1%. Then oxygen. Oxygen has a mass of 192, and it makes sense that it's going to have a higher percentage. I could also add those up and subtract it from 100, and that would give me the percentage of oxygen. We'll do it mathematically. Okay, 192 divided by 342.14 grams times 100 equals 92 divided by 42.14 times 100 gives me a percent of 56.1%. That's pretty awesome, right? So that means there's only, 3 sulfurs, and a lot of the mass comes from there. Aluminum, there's 2 aluminums, but it's not that dense. It's not that heavy. So anyway, let's go ahead and do 11, and we'll call it an end to this video anyway. So you have a compound that contains a complex ion, and it has the formula aluminum 4, iron cyanide, which is 6. Okay. Yeah, I don't even know what the name of that's just going to be very difficult. What is the percent by mass composition of the compound? We're going to do the same thing, but we have to get our components right? The right number of components. So aluminum, if you look at the compound, I've got 4 of those. Now notice this is not in the brackets, so we're not going to worry about that. And aluminum has a mass of 26.98 grams, atomic mass of that. So let's look at the next one, iron. Now let's look, iron, all right, there's a 6 besides that parentheses, and the iron is in the bracket, so what that means is that there's 6 of these CNs. Now, there is a bracket, and there's a 3 outside the bracket. What that means is that the 3 carries over to each of those parts. So I told you there's 6 of those, that means there's 18 nitrogens, 18 carbons, and then only 3 iron. So I'm going to put 3 times the mass of iron is 55.85 grams. All right, now add those up, it'll give me. So again, I told you there are 18, 3 times 6 carbons. So that's 18 times 12.011. And then nitrogens, there are 18 nitrogens. The 6 goes over and the 3 goes over. It distributes across those brackets and those parentheses. So that's 18 times 14.007 grams. So let's start doing some math. 18 times 8.007. That gives me 252 grams of nitrogen. 252.126 grams of nitrogen. 18 times 12.011 grams is 216.198 grams. 3, okay, the iron, that was 55.8. Iron 85. It's going to give me 167.55 grams. Then aluminum, 4 times 26.98, because that's the mass of aluminum. I get 107.92 grams. 107.92 grams. So I've got to total all these up just like I did with those other problems. And if I total all those up, 67.55 plus 216.198 plus 252.126 gives me a grand total of 743.794 grams for the total. That's a large molecule, okay? Very large and very heavy. So now we've got to get our percentages right. So aluminum, I take the mass of the submass, if you would, of the aluminum, 107.92 grams. And I divide through by the total, 743.794 grams. Multiply by 100, and that's going to give me 107.92 divided by 743.794 times 100. I'm just going to do that. So I get 14.5%. Iron. Again, not a lot of iron. Let's see what that mass is. 167. So it's going to be a little bigger than that. Again, let's just use our mental math and make sure it makes sense. Divided by the total, 743.794. 67.55 divided by divided by 743. Sorry, I gotta get the right buttons. 167.55 divided by 743.794 times 100 is equal to 22.5%. A little bit bigger. That sounds about right. So let's look at a carbon. Carbon has a mass of 216.198 grams. Divided by the total, 743.794. We're getting a little repetitive here, aren't we? But that's really about the only way you can do these problems. Just be repetitive. 743.794. 100, and that's going to equal 29.1%. And that sort of makes sense. It's a little bigger than that. Let's look at nitrogen. Nitrogen is equal, let's get this up to where y'all can see it. Nitrogen. Okay, nitrogen, over a little bit. Nitrogen is 252 grams. 126 grams divided by 743.794 grams times 100, and that's going to equal a little bit more than that, 252.126 by 743.794, and that's going to be 33.9%. Now, the cool thing about these problems are, if I wanted to check my work, 33.9 plus 29.1 plus 22.5 plus 14.5 should mass out to, sure enough, 100%. So that means we did that problem right. So guys, that's all the, those are 3% compositions, mass compositions. Red Devil Chemists, you guys have got this. I imagine you may see at least one of these on a test. So Coach Scott saying from Worksheet 4S, problems, I don't know, 9 through 11. 9 through 11, enjoy them, check yours, and have a great night.